solving systems by substitution. First of all, we'll do a couple of problems that were like the ones we saw in our last assignment, just to make sure we understand how that worked. So we mentioned that if one of the equations in our system has been solved either for x or for y, we can take what it says that y is or x equals and substitute it into the other equation for that variable. So on our first example here, we will end up with 4x subtract 5 times 2 equals 14. And then I need to do a little simplifying, so I'll get 4x minus 10 equals 14. And now we're going to add 10 to both sides. And we will then simplify it a little bit further, and we'll have 4x equals 24. So as I do that, I start to realize that all I have to do now is divide both sides by 4, and I end up with x equals 6. So now I have my two numbers. I have 6 for x and 2 for y, so my solution would be 6, 2, which basically means that if I graph both of those lines of those equations, this is the point where they would cross. Okay, let's try one more. It's very similar to the one we just did. So once again, we recognize that y has been solved in the first one, and it equals 2. And if we graph that, that would actually be a horizontal line going across the graph at 2. So now we're going to substitute that 2 in for y in the second equation. And then we write out our new equation, 5x plus 2 times 2 equals 4. And as we simplify it, we end up with negative 5x plus 4 equals 4. And when we subtract 4 from both sides, we end up with negative 5x equals 0. Now, in order for this to work, the x has to be 0, so that negative 5 times 0 would give you 0. So x does, in fact, equal 0 on this one. And we already know what y is up here, so let's write our final solution then, 0, 2. So there's that one. Okay, so what new things could we throw in there today? Well, what if when x or y is solved in one of these equations, I don't just get y equals negative 2, but I end up with y equals negative 2x, something like that. Well, you do the same thing. You take whatever says y equals and then substitute it into the other equation for that variable. So let me show you how that works. So we're going to basically move the y out of the way, and we're going to put negative 2x in its place up here. And we've got to remember to go ahead and put some parentheses around it so that when we multiply it, we'll know exactly what we're doing. So when we multiply that out, we end up with negative 4x minus 4x equals 24. When you combine those two negative 4x's, we get negative 8x equals 24. And that would result in us dividing both sides by negative 8. And we would end up with an x value that was equal to negative 3 when we did this division. So if x is negative 3, now all we have to do is find y. Now remember, y was equal to 2x when we first started. So now we just have to plug negative 3 in for x, and we will end up with negative 2 times -3, which equals 6. So our y value will be 6. So our final solution then is -3, 6. All right, that's a little more complicated, but not too bad. Let's try a couple more. So in this case, we've got x equals 4y, and 2x minus 3y equals 25. All right, so we know that this says x is 4y, so we're going to replace this x in the other equation with that 4y. So I'm literally going to move this out of the way. I'm going to grab that 4y and bring it down. And we want to make sure maybe we can shrink it down just a little bit, give ourselves a little more room. But we want to put some parentheses around it so that we know that we are multiplying now. 2 times 4y. And 2 times 4y is 8y. And then I have still there a minus 3y. And that equals -25. So let's combine our like terms on the left side here. 8y minus 3y is 5y. And 5y equals -25. All right, so let's divide both sides by 5. And we end up with y equals -25 divided by 5, which is -5. So there's half of our final solution. And we know that x is equal to 4 times y. And now that we know what y is, we can just substitute it back in up there and do 4 times -5, which equals -20. So our x value is -20. And if you notice, we're getting some big numbers. And so if we were graphing these would be way out there. So another reason why we want to learn how to use substitution is so that we don't have to make great big graphs. So our final answer would be -20, -5. And that would be the solution to that system of equations if we graph both of them. All right, let's try another one. In this case, we're saying y is equal to -3x. And so we're going to replace this y with that -3x. So let's do that. Take our 4y, take our y out of there. Move that out of the way. And then we'll take 3x and drag it up and put it in there. We'll shrink it down so it's got a little room to fit. And then we need to put parentheses around it because we know that we are multiplying 4 times -3x. And when we do that, we end up with 10x minus 12x equals -14. And then 10x minus 12x is -2x, all equal to -14. So when we divide both sides by -2, we end up with our final x value of 7. Okay, so if we know that x is 7, we can take that 7, bring it back up, and substitute it in for this x right here in order to find out what our y value is. So we'll end up with y equals -3 times 7, and that equals -21. So y equals -21. So as you can see, these take a little bit of work, but they're not that hard. So 7, -21 is our final solution, and we're good to go. So we just have an Alex assignment for you to do, and since you have to show some work to do these, we've also got this box paper so you can show your work on each problem, how to do that. Thank you very much.